Fourth lecture.
Two exercise to सिद्धिसक्यो हैन र म्याम
Exercise number 9 सिद्धियो
फोर्थ हुन्छ आज सायद
ए हो
हजुर म्याम त्यो
हजुर
ए तिमीहरुको त मैले त धेरै मिस भएछ कि क्लास भन्न ठाने थिए यो सबै कम्प्लिट भइसक्यो
अब चाहिँ इन्टिग्रेसन एज लिमिट अफ सम पढ्ने भन्नुभएको थियो
हैन हैन त्यो तिमीहरुको कोर्समा छैन भनेको थिए मैले वी आर गोइङ टु स्टार्ट इम्प्रोपर इंटीग्रल
ए त्यस्तो
you have to note down that integration as a limit of sum is not in your course. So we are going to start with improper integral. So let me let's just first of all discuss what is improper integral. Those who are not speaking, you can please mute yourself. Mute garu mai afai mute garu. Okay. Suppose your limit of integration is like this, and you have any function, कुनै पनि function छ, and your integral, look at limit of integration, it says that you have to find out area of this function starting from 0 but ending at infinity. So do you think it is practical situation? How is it possible that we find out, you see your lower limit is finite, okay, you know that where you have to start from 0, but do you know where you have to end? Do you know your end point? No, exactly. You don't have any endpoint. Okay, so suppose this is your f of x. So your situation is like this, that you have to find out area from here, but you don't know kata samma area find out garne. That's why this is impractical situations. That is why we call this type of integral as improper integral. Okay, improper integral. Okay, this is one example. Okay, what could be the other possibility? Suppose your lower limit, yes, your lower limit is minus infinite. Okay. So you know that you have to integrate from till to कुनै एउटा curve छ. Let's take same curve. Okay, you know that your upper limit is 2. That means you have to find out area till 2, but you don't know its starting point. Okay, you don't have any point to start. So this is also impractical situation. This is also improper integral. What could be other possibility? Can you think of anything else?
त्यो रेन्ज भित्र चाहिँ फंक्सनको भ्यालु नै एक्जिस्ट नगर्ने पनि हुन सक्छ नि त.
Very good. That is also one possibility. Okay, and now we have seen just now मैले जुन दुईटा example जुन limits of integration को कुरा गरे, that was improper integral due to limits of integration. Okay, limits of integration ले गर्दा फेरि हाम्रो integral improper भयो. That means either your lower limit is infinity or your upper limit is infinity, or both the limits are infinity. That means you are starting from minus infinity and ending at plus infinity. Okay, so you can have this situation also. I know this is also possibility that you don't know your starting point, your end point. So this is also one of the possibilities. So what are we going to do in this case? I know you have done integration where you were dealing with limits of integration having infinity. Okay, but you never realized यसलाई practically सोचेन कि यो infinity को के meaning हो, why is it what is it doing to our integral? So you are never thought of it. You were just looking for the solution. I know, but it's like graphically तिमीले assume गरेन. Most of you, I am not telling कि सबैले कसैले पनि assume गरेन, but most of you have not thought about it. But you should know that it is improper integral. So in this case, what are we going to do? Whenever we talk about infinity in function, function को बीच में कति infinity को कुरा आउँदा फेरि what concept we introduce? We introduce concept of limits, है ना? Okay, so how are we going to do that? We will discuss later. So let's say that suppose your lower limit is 0, upper limit is infinity. So what are we going to do? We are going to say let your upper limit be b. हामीले के भनौं कि let b is your upper limit. त b लाई हामीले एउटा finite number assume गर्यो. But at the time you have at the end you have to apply the concept that your b tends to infinity. So we are going to solve our integral assuming that your upper limit is constant, and at the end we are going to apply concepts of limits. किनकि जब infinity को कुरा आउँछ हामीले limit को concept use गर्यो भने हाम्रो solution सजिलै आउँछ. Okay, so let's look at all the cases one by one, all three cases which we have discussed right now. Okay, so first case, I've just mentioned how to deal with this. You can see your lower limit is constant a, upper limit is infinity, your integral is infinity, your improper integral due to upper limit. Okay, so what are we going to do in this case? We are going to solve this integral. Okay, हामीले एउटा integrals यो integral लाई solve गरौँ assuming that b your upper limit is also constant. But at the end, you have to replace your b by infinity and apply the concept of limits. Okay, if you face this situation, b राखेर यस्तो situation आयो भने के गर्ने? If you don't apply the concept of limits, how will you tackle with this problem, isn't it? Okay, so that's why we require concept of limits here. अब यस्तो सिचुएसन आएन भने इट्स नट अ प्रब्लम, तिमीको सल्युसन लिमिट अप्लाई गरेर पनि नगरेर पनि सेम नै आउँछ. बट यस्तो कुनै सिचुएसन यस्तो आउन सक्छ जसमा हाम्रो लिमिटको कन्सेप्टले मात्रै तिमीको सल्युसन दिन्छ. ओके, दैट्स व्हाई टु अवॉइड दैट सिचुएसन वी हैव टु अप्लाई concept of limits. Second case, it's quite obvious. Here your lower limit is infinity, minus infinity. You all can see हैन स्क्रिन मैले जसरी जसरी बोल्दैछु स्क्रिन अपियर हुँदैछ कि देयर इज टु मच अफ टाइम ल्याग
छ त्यतिखेर नै भएको छ
भइराछ है. ओके, दैट्स गुड. सो इफ यु फेस एनी टेक्निकल प्रब्लम प्लिज लेट मी नो. ऑल राइट, सो माइनस इन्फिनिटी. मेरो साउन्ड पनि क्लियर छ? काटेको त छैन नि?
एकदम क्लियर छ म्याम.
ओके, सो माइनस इन्फिनिटी टु सम कन्स्टेन्ट b. तो यहाँ चाहिँ हाम्रो लोअर लिमिटले गर्दाखेरि your integral become improper integral. So what are we going to do? We are going to use same concept. We are going to say that limit a tends to minus infinity a to b f of x dx. हामीले integral ला पहिला proper integral assume गरेर solve गर्ने, and at the end we are going to replace a by minus infinity, or you can do one thing, limit a tends to infinity minus a to b. You can go both ways. Okay. Next scenario is when you have, okay, can you yes, let's do one thing. Let's talk about this improper integral, because both the limits are infinity, minus infinity to infinity. In this case, what are you going to do? You are going to break your integral into two parts. दुईटा पार्टमा डिवाइड गर्दा फेरि you see you remember properties of definite integral. हाम्रो के थियो? a to b f of x dx can be written as a to c f of x dx, c to b f of x dx. Same concept हमले यहाँ use गरे, where you see you know that minus infinity and infinity को बीच में एउटा zero lie गर्छ हैन? So you can break your integral into two parts. You can say that your first part is minus infinity to 0 and second part is 0 to infinity. So quite satisfied. All right, so अब यसमा चाहिँ दुईटैलाई separately limits, because दुईटा limit एकैचोटी लगाउँदा त confusing हुन्छ नि. That's why to avoid this part we have to break your integral into two parts. So दुईटामा divide गरेर limit एउटा first मा चाहिँ a tends to minus infinity, and in case of second a b tends to infinity. This is also clear. Now one more another case is, अहिले हामीले तीनटा केस डिस्कस गर्यो. All these three cases were improper integral due to limits of integration. Okay, but one of you already mentioned that you can have situation where your function becomes infinity. Okay, so let's discuss that part. Suppose you have this situation. Let's say this is a. This is b. So here you have to find out this area of this function. But what do you observe? That your function is discontinuous at lower limit. Okay, timako a lower limit, b is upper limit. You have to find out area from a to b, but what is happening that your function is becoming discontinuous at point, your function is discontinuous at point a. So a matlab problem भयो, a bata b सम्मको area कसरी find out गर्ने. So how are we going to tackle this problem? We are going to assume, or we can say we are going to find out area from here, that is
A plus H.
yes, a plus h. A little bit, we will go a little bit ahead of a भन्दा हल्का अगाडि शिफ्ट भएर अब यहाँदेखि यहाँसम्मको एरिया फाइन्ड आउट गरौँ. अब त अलि हाम्रो प्रब्लम सर्ट आउट भयो नि हैन, where h is very very small. Okay, where h is very very small means what is it? Where limit h tends to
0.
exactly, हैन, h tends to 0. So this is how we are going to deal with such problem. यहाँ चाहिँ lower limit in discontinuous भयो. Let's say that, let's change the scenario. Let's say that this is b, upper limit, and your lower limit is here. What happens in this case? How will you find out area in this case? Your function is discontinuous.
B minus H गर्नु पर्यो.
Yes, okay. So हाम्रो के छ, हाम्रो तरिका कि हाम्रो जुन problematic portion छ नि, त्यो problematic portion लाई हाम्रो integration मा include नगर्ने. We are going to avoid that problematic part. So which part is problem here? This B part. So what are we going to do? We are going to integrate from A till B minus H. B सम्म नपुगौँ न, B भन्दा हल्का अगाडिसम्म integrate गरौँ न. Okay, so we will do that again where H tends to infinity. All right. We can have one more situation. Let's use this graph only. Let's say that your function is discontinuous at point C, which lies in between A and B. अब A देखि B सम्मको area, how to find out? Your problem lies at C.
C लाई ब्रेक गर्ने, एउटा चाहिँ A देखि
A लाई
H सम्म,
C minus C plus
C
H.
plus H देखि B सम्म.
Very good. Okay, so we will do this thing. We will integrate from A till C minus H. So we will find out this area. Then we will start from C plus H and we will reach till B. Okay, so your problematic part was the C. We have in this scenario we have splitted our integral into two parts and we avoided the C part. यहाँ C मा problem थियो, यो C ला अब हामीले के गर्दियो? Ignore. Okay, so you can see हामीले यो यसलाई हाम्रो integration मा area को part मा हामीले include नै गरेन. All right, where definitely your limit h tends to 0. Okay, so this is clear. So let's see one by one all these three cases. Your fourth case, when your function becomes infinite at as x tends to a, f of x tends to infinity as x tends to a means because of lower limit a को कारणले तिमीको function के भयो? Discontinuous. Okay, so a मा function discontinuous भयो नि के गर्ने थियो हामीले? We will avoid this a part. A भन्दा हल्का अगाडि बढ्ने, that means a plus h देखि b सम्मको integration. So limit h tends to 0. We have already discussed this in detail. So I will just be slightly quick now. Okay, so here next case, fifth part, your function becomes infinite when x tends to infinity. Okay, so your function is discontinuous at b, where b is your upper limit. So upper limit ma discontinuous भयो नि के गर्थे हामीले? We will start from a, but we will not reach till b. We will avoid b part अनि b भन्दा हल्का अगाडि, that is b minus h सम्म मात्र integrate गर्ने. Definitely h tends to 0. Okay. Next, last part is when your function becomes discontinuous at point C, where C lies between A and B. So what will you do? You will break it into two parts. Duita integral ma divide गर्ने. You will start from A. You will reach till C minus H, then C plus H dash देखि B सम्म. Okay, so graphically हामीले हेरिसकेछ, बुझिसकेछ. What does it mean? All right, now do you notice something? That I have taken two different limits here. First is H, second one is H dash. Okay, so
Yes,
why we are taking two different limits, that I will explain later. So don't ask me this question in the beginning. I'm leaving this part for the last question. Okay, last your exercise last question I will explain this, because there you can clearly see the difference why you need to take two different limits. What is the reason? Okay, so I will tell this later. Now let's start with the exercise. Kate doubt, sir? No. Okay, let's start with this question. Can you tell me why is this improper? Let me ask one of you. Let me pick your names. Achal Shakya? Achal?
It's Achal.
Achal. Okay.
Upper, yes, ma'am.
Hello. Okay.
Yes, ma'am. Upper limit is infinite.
Yes, exactly. Upper limit is infinity. So what will you do in this case? Do you remember? Do you remember what to do?
B tends to infinity and it similarly.
Yes. Limit b tends to infinity and your upper limit will be replaced by b. Okay, so this is your new integral now. Abad say, what are we going to do? We will use this part at the end. I know. End my use garum. Abad say, you have to integrate this part. Now, what is the integration of this function? Very easy. Direct result you have. What is it?
Sin inverse हुँदैन.
What are you saying?
1/2a log a minus x by a plus x हुन्छ क्या?
No.
A plus x by a x some no x minus a by x.
X square. I think this x square minus 9 होनु पर्ने.
A 9
It's 9.
minus
9 हो, म त a जस्तै मान्दै.
tan inverse मा कसरी आयो म्याम?
मैले क्वेशनमा मिस्टेक गरेछ.
1/6 अनि log को फर्ममा जान्छ कि उतापट्टि चाहिँ 3 - x by 3 plus x.
यहाँ प्लस हुनु पर्ने, मैले माइनस गरेछ के.
यो प्लस हो,
Yes.
माइनस छ भन्दै चाहिँ त्यो log तिर जान्छ.
Yes, minus 7. Yes, it's correct. Okay, plus हुनु पर्ने. Now it's very easy, है ना? 1/3. I missed 1/3 also here. 1/3 tan inverse of x by 3 direct formula छ हैन? So अब के गर्दिने? You have to now apply limits of integration. 1/3 is already there. Can you give me answer? What is your final result? What is the answer in this case?
Pi by 6, ma'am.
Yes, exactly, pi by 6. Pi by 6. So you see, your final answer is pi by 6. Now we will observe this. We will talk about the solution later, but let's talk about another question, similar question. Okay, so very easy integration. Only you have to take care कि तिमीको limits of integration improper छ कि छैन, improper छ भने how to deal with it. Okay, so we have same problem here. Your upper limit is infinity. So what will you do? You will introduce concept of limit. Okay, b tends to infinity. Replace your upper limit by b. Then solve your integral. So यसको solution धेरै सजिलो छ. You see, if we multiply numerator and denominator by 2, numerator and denominator like 2 ले multiply गर्ने, you see that numerator is derivative of denominator, this x square plus 4. Okay, so 2x is derivative of x square plus 4. That's why you can write the result of this integral quite easily, 1/2 log x square plus 4. So limits of integration is 0 to b. Now let's apply limits of integration. Can you tell me what are you going to get from here when you replace your b by infinity? What is log 0 plus 4? It's a constant. I know this second part. Second part is constant. So let's observe this part. When you replace your b by infinity, what happens? What will be your result from here? Can anyone tell me?
0, ma'am.
0. My goodness.
Exist.
Any other?
Does not
Any other?
exist.
Infinity.
What?
Zero.
Let me tell you. Okay. What is infinity square? B square. And what is infinity square?
Infinity.
Infinity square is infinity. Infinity plus 4 is infinity. And what is log infinity?
Log 1 minus log 0.
What?
हुन्छ त्यो भ्यालु हुँदैन
के भन्यो?
इन्फिनिटी नै हुन्छ होला म्याम, किनभने इन्फिनिटीको पावर इन्फिनिटी भनेपछि इन्फिनिटीको लग पनि इन्फिनिटी हुनुपर्ने हो।
Infinity को power infinity? No, you are using another concept. Yeah, so I will explain this. Why is it infinity? It will be clear. Can you tell me first thing? Just tell me one thing. Yeah, log infinity equals to infinity लिख्नु भन्दा अगाडि keep this in mind. What is your base of log?
10.
10.
Exponential, ma'am. E.
We are talking about natural log. Okay. Whenever we are simply saying log, यहाँ जुन हाम्रो log आउँछ नि integration मा, that is natural log. Okay, its base is e. Okay, keep this in mind. Now, what is e to the power infinity? What is e to the power infinity?
इन्फिनिटी नै हुन्छ।
Infinity huncha, हैन? That's why log of infinity is infinity. This is the reason. With both sides, take log both sides, you will get log infinity equals to infinity, isn't it? Are clear, sir? Now use same logic and tell me what is log 0. Use same logic and tell me what is log 0. And finally tell me what is log infinity, minus infinity, sorry.
मैम log 0 एक्जिस्ट गर्दैन होला।
Any other answer?
इन्फिनिटी हुन्छ लग 0 को।
माइनस इन्फिनिटी हो कि
Minus infinity.
Very good. Minus infinity. Few of you said minus infinity. Yes, that's good. Why? Just look at it here. What is e to the power minus infinity?
0.
Yes, that's the reason. Okay. Thank you.
Yes, 0.
I would say log minus infinity को चाहिँ कुनै solution नै छैन. Indeterminate. Sorry. Okay. So you have no conclusion for this. Okay. Only log infinity is infinity. Yes.
मैम यो जुन यसलाई हामीले ग्राफबाट स्टडी गर्दा नि हुन्छ हैन, ग्राफबाट हेर्दा नि हुन्छ हैन?
हुन्छ. Yes. Now we are going to look at it graphically. Now we will look at it graphically. मैले graphical part कुरै गरेको छु अहिले. Yes.
लग इन्फिनिटी छ नि?
Yes.
त्यो लग इन्फिनिटीलाई हामीले log 1 minus log 0 गरेर देखाउन खोजियो भने के हुन्छ त? रङ हुन्छ कि हुँदैन? हुँदैन होला हैन?
Log 1 minus
log 0. आउन त आन्सर उही हो, हुने त तरिका त्यही नै हो.
You mean to say log 1 over 0 भनेर?
हजुर हजुर हजुर.
अनि फेरि तिम्रो पछाडिपट्टि जसरी लग इन्फिनिटी आउँछ नि त फेरि त्यही आयो
हुन्छ त्यस्तो नि
आन्सर त्यही
infinity नै आयो नि. Log 0 is minus infinity.
फेरि त्यसरी छुट्याउँदा त log 1 प्लस फेरि log इन्फिनिटी आयो नि त, हाम्रो log इन्फिनिटी को भ्यालु प्रुफ गर्न छ, फेरि पछाडी त्यही
log minus
के भन्छन् केटाहरु, log 1 minus log 0 भन्दा छु, log 0 को भ्यालु माइनस इन्फिनिटी हो, आन्सर आउने उही हो, तर गर्न मिल्छ कि मिल्दैन म्यामले सोधिरहेको क्या मैले.
log 0 minus infinity हो अनि 0 minus minus
solution तिम्रो त सेम नै आयो. Solution सेम नै आयो.
सोलुसन सेम आयो तर मिल्छ कि मिल्दैन भनेर सोधेको क्या.
कस्तो केसमा मिल्छ कि मिल्दैन भन्न खोजेको, कुनै केस कुनै उसमा log infinity छ अनि you want to for simplification you want to replace it by log 1 minus log 0.
हजुर हजुर.
डिपेन्ड अन द सिचुएसन है हामीलाई जरुरी नै छैन भने त जबरजस्ती रिप्लेस गर्ने कुरो भएन कुनै कुनै केसमा अब हामीले सोल्युसनको लागि गर्छौं नि हैन धेरै ट्रिक्सहरु अप्लाई गर्छौं त्यो केसमा चाहियो भने यस यु क्यान राइट इट ओके
यो त 5 लाई 3 + 2 लेख्न मिल्छ कि नै भने जस्तै हो यार
so now let's observe this we have just discussed how we got infinity कसरी आयो but do you realize one thing मैले अब चाहिँ के डिस्कस गर्न खोजेको भने you remember what is your starting point you have two different functions but you have same limits of integration 0 to infinity but what is happening look at first solution you have pi/6 as your answer look at second solution your answer is infinity so can you tell me your data solution बाट कुन solution चाहिँ expected थियो if you don't look at graph curve right now we just look at the integration part limits of integration which was expected answer
number
second one isn't it you if you close your eyes and imagine that what will be area of curve from 0 till infinity सम्मको area find out गरिरहेछ त हामीले त constant imagine नै गर्दैन we will assume that it will definitely be infinity okay so in second case you have got infinity but in first case you have got very small number constant pi/6 is a very small number isn't it so why you got such a small number as a solution can you think about it
यस म्याम कहिलेकाहीँ
यस म्याम यो डिनोमिनेटरमा छ फर्स्टको चाहिँ सबै कुरा अनि सेकेन्डको चाहिँ न्युमेरेटरमा पनि छ नि त अनि डिनोमिनेटरमा भएपछि घट्दै घट्दै जान्छ अनि इन्फिनिटीमा एउटा कन्स्टेन्ट भ्यालु आउँछ
your reason is right in this short term यसलाई short मा भन्यो भने you can say that your curve is convergent हैन यसलाई short मा भन्यो भने convergent curve भयो something like this okay your curve is giving certain values 0 मा त certain values छ किनकि 0 त आछैन नि हाम्रो एरिया सो 0 मा certain value छ अगाडि सम्म पनि हल्का curve like certain value दिइरहेछ but your curve is decreasing but after certain amount after certain value of x को certain value पछि you can see that your function is not giving you any value I mean zero value you can say हैन तिमीको function के भइदियो 0 भइदियो after certain values of x so what will be your area what is your area only this much is your area so whatever large your upper limit is doesn't matter in this case however large your upper limit is your area will be very small quantity okay area is very small that's why in first case you can do one thing you can compare area curve of both the cases similarly curve tracing you can do you can use your softwares के apps हरु छ नि हैन graph plot गर्ने you can use that use those applications and plot your graph and you can observe your graph first case मा चाहिँ तिमीको conversion curve हुन्छ त्यही भएर तिमीको very small area आयो अनि second मा चाहिँ conversion छैन okay it is your nature of the curve is not like this maybe something like this increasing decreasing increasing ani 0 नभएर suppose constantly suppose it is like this in what this case what will happen suppose after certain value of x your f of x is not 0 it is but it is giving very small value let's say 0.7 value भए पनि आइराछ till infinity it is giving certain small value then what are you going to get in this case
यसमा पनि 0.7 आउँदैछ अझ अगाडि बढ्दाखेरि 0.7 कम आउँदै जान्छ
एट इन्फिनिटी माइट बी 0
इन्फिनिटी नै आउँछ नि हैन सर्टेन स्मल भ्यालु भएर पनि त्यसलाई इन्फिनिटी सम्म इन्फिनाइट टाइम्स एड गर्दै गयो भने त इन्फिनिटी नै आउँछ नि ओके सो इन दिस केस आल्सो योर solution will be infinity okay so we have just discussed in what case you are going to get finite answer and in what case you will get infinite answer so now let's look at another one how much time do we have okay now let's look at last question third question yes I want you to observe this integral and tell me what's happening here till then let me get water for me
0 मा चाहिँ फंक्सन इन्फिनाइट हुन्छ
म्याम 1 भन्दा तलको कुनै पनि भ्यालुमा यो फंक्सन इन्फाइनाइट रहेछ
Yes. Have you observed this?
यस म्याम
Okay, so what's your conclusion?
1 भन्दा तलको कुनै पनि x को भ्यालुमा यो फंक्सन अनडिफाइन्ड रहेछ
हैन a भन्दा ठुलो भ्यालुमा र 0 मा
ए भन्दा
Zero मा हैन?
0 भन्दा सानो
ठुलोमा चाहिँ कम्प्लेक्स
माइनस भएको भएर हुने भयो
Complex भयो yes complex also तर discontinuous कुन value मा भयो
0 मा र 0 भन्दा तल
0 मा
0 मै हुने भयो
a भन्दा ठुलोको त कुरै छैन we are not bothered about it because हाम्रो upper limit नै a हो हैन but lower limit मा problem भयो lower limit because of lower limit your function is becoming discontinuous okay so your situation is like this so tell me how to deal with this 0 मा चाहिँ curve discontinuous छ okay 0 is a starting point a is a end point yes okay
lower limit as tends to 0 गर्ने
yes exactly so this is how you are going to deal with this we will introduce function discontinuous on the head we have to talk about h I know so we will introduce h we will say limit h tends to 0 your lower limit is 0 plus h so I simply h likhe okay it means same 0 plus h till a now you have to integrate अब चाहिँ integration गर्नु पर्यो do you remember how to integrate this type of function how do you integrate this type of function come on by substitution you assume this substitution x ला t square मान्यो भने easily solve हुन्छ है तिमीहरुको problem okay so when you substitute your limits of integration will also change you will also find out okay so you are assuming x equals to t square so dx will be equal to 2t dt your new limits of integration will be root h to root a okay yes त तिमीको finally के आउँछ यो t denominator को t र numerator को t cancel out हुन्छ and you are just simply remain left with a minus t square which is a standard form integral in standard form यो यसको तिमीसँग direct formula छ isn't it so what is it you have to integrate root under I'm 2 is there root under a minus t square dt इसको integration गर्नु पर्यो how do you integrate this function do you remember I've asked this formula in the beginning
त्यसमा त्यो t by 2 अनि square root of a minus t square and sin inverse plus sin inverse
plus a square by 2 sin inverse x by a
x by मैम त्यस्तै
यस्तो छ यहाँ चाहिँ a square को कुरा you are right you have used correct formula but यहाँ चाहिँ a square को ठाउँमा चाहिँ a छ that's the only difference
हजुर
only difference is that so you can compare with that formula which you just mentioned let me write down that formula also your formula is for function a square minus x square dx यसको formula बन्यो हैन भर्खर यसको formula के छ it's
x by 2 root over a
yes
square minus x square
yes
plus a square by 2 sin inverse x by a
yes but what's the only difference your a is replaced by sorry a square is replaced by a त जता जता a square छ त्यसमा a ले replace गर्दिने अनि a भएको ठाउँमा root a ले replace गर्दिने so let me also है a square लाई square हटाइदियो x को ठाउँमा t okay, you assume that x को ठाउँमा t छ, so you replace this square also, you replace this square also. तो यहाँ से final a में क्या होता है, root x by root a. So now you will integrate. What is the limits of integration? Root h to root a. Do one thing. Apply this limit of integration and finally give me your answer. This part do on your own. Paila upper limit is root a, so where is x, replaced it by a root a, x ko ठाउँमा root a, and then wherever there is x, replace it by root h, and finally you will put your h equals 0. So what are you going to? Quite easy to solve.
Ma'am,
so I'm waiting for answer.
म्याम यो प्रोसेस त पहिलाको जस्तै छ त म्याम, लगभग लिमिट राख्दाखेरि लास्टमा उस्तै आउने हो, लिमिट राखेर फाइदा चाहिँ के भइरहेछ?
मैले बिगिनिङ मै एक्सप्लेन गरेथे है, देयर आर सर्टेन केसेस, हाम्रो मोस्ट अफ द केसमा लिमिट लगाएर पनि नलगाएर पनि फरक नपर्न सक्छ हैन, तर लिमिट कन्सेप्ट पर्यो, किनकि यु माइट फेस एनी सिचुएसन लाइक दिस. सपोज तिमीको सल्युसन फाइनली तिमीले अप्लाई गरे लिमिट्स इन्फिनिटी छ भने इन्फिनिटी, फंक्शन डिस्कन्टिन्युअस भइरहेछ भने फंक्शन व्हाटएभर इट इज, बट फाइनली इफ यु गेट दिस सिचुएसन, यो केसमा हाम्रो सल्युसन डाइरेक्टली केही लेख्न मिल्छ, केही भन्न मिल्यो, यो केसमा त हाम्रो लिमिट लगायो भने हाम्रो आन्सर आउँछ नि हैन, मेबी आउन सक्छ नि हैन.
म्याम यो केस भयो भने सिधै एल हस्पिटल लाइदा हुन्छ है?
लोपिटाल्स रुल, or 0/0 आइदियो भने, or 0 to power, what is it, 0 to power infinity हैन, so 1 to the power infinity whatever, तिमीको indeterminate form
a pi by 2 man, a pi by 2
हैन, तिमीको ए आन्सर आइसक्यो a pi by 2. yes correct. Okay, so if you get this type of indeterminate form तिम्रो सल्युसनमा आयो भने त यसलाई सल्भ गर्नको लागि त लिमिट्स को कन्सेप्ट चाहियो नै, त्यसको लागि हो हामीले लिमिट्स युज गर्ने. ओके, बट अहिलेसम्म तिमीले डिल गरेको उसमा चाहिँ फरक पर्दैन, लिमिट लगाए पनि नलगाए पनि सेम आन्सर. आवाज काट्यो, मैले केही बुझिनै. Anup, I'm unable to hear you. Your voice is cracking. Yes, Vishal, you want to say something? Ashutosh, what's your answer? Angela? Angela?
Ma'am?
What's your answer?
नाइ म्याम, मैले त गरेन, बिचमा गएर अड्के.
सल्भ गर्न सकेन, लिमिट सप्लाई गर्न सकेन?
हजुर, म गर्दैछु म्याम.
ओके,
ट्राई गर्छु.
ओके, सो लेट मी जस्ट क्विकली रफली टेल यू. अहिले क्विकली भनिदिन्छु है. You see, when you replace x by a, let me use another color. X को ठाउँमा a राख्दा फेरि यो टर्मले गर्दाखेरि 0 भयो हैन? Getting it?
Yes ma'am.
है, यहाँ चाहिँ के भयो, a by 2 sin inverse root a by root a, sin inverse of 1 भयो. x को ठाउँमा root a राख्दाखेरि root a by root a sin inverse of 1 भयो. Now when you replace it by h, and finally h like 0 राख्नु पर्यो हैन? So what happens? Look at first term. Let me use another color now. I'm using green color for lower limit. H is 0. So यहाँ बाहिर जुन h छ त्यसले 0 बनाइदिनु भयो this term. So this term also becomes 0 for lower limit, and you will get 0 here. Sin inverse of 0 is again 0. So this term also becomes 0.
Ma'am, a
So
pi
when
by
you replace,
4 हुनुपर्ने नि answer?
A by 4 हुनुपर्ने म्याम।
हजुर त नि
oh
4
yes,
So
oh
माथिको
yes,
2
a by
लेखेको
2,
y by
a by 2. So yes, so a by 4 is the answer. Okay, a by 2 already outside, and sin inverse of 1 is pi by 2, so you will get a pi by 4. Okay.
उतातिर 2 पनि छ नि त, उता 2 ले मल्टिप्लाई भइरहेछ
Oh
नि त
yes.
इन्टिग्रेल।
अझै एउटा 2 रहेछ यहाँ, यहाँ छ नि त इन्टिग्रेसन बाहिरको, त्यसले गर्दा फेरि अगेन you will get a pi by 2. Yes. So the conclusion is solution त सजिलै आउँछ नै. So what is your conclusion? You have got this a pi by 2 constant result here also. But last we have 2 questions. म यो दुईटा चाहिँ सँगसँगै डिस्कस गर्न खोजेको. So today time हाम्रोलाई sufficient भएन. We will discuss this next week. Okay, you have to remind me. And मैले बिगिनिङमा जुन मेन्सन गरेको थिएँ h र h dash किन फरक लिनु पर्यो, that answer you will get from these questions. All right. So that's all for today. So we will conclude this next week and we will start new topic also. Any queries, any question, anything to ask?